We are live. So in today's video, I'm going to talk about just kind of a really brief introduction to Pandas. And Pandas is basically a library that allows you to work with spreadsheets in Python to import, spreadsheets or spreadsheet-like data sets. So it doesn't have to be necessarily an Excel spreadsheet, but it can also be a comma separated variable, which is kind of a default text form for a spreadsheet. So again, we're just going to use pandas, and typically if you look at most examples, people use pandas as PD. I will qualify this this video by stating that I am not an expert in pandas by any means, but I'll show you how to basically do some basic things in it. So we're going to start with data is equal to PD, which is for pandas, and then we're going to read Excel. And in some of the examples I've given you, basically XLSX. I've also done read CSV or a different kind of data file. So we can do this, and we didn't get an error, so we kind of read it in our data set. And in this case, we can just take a quick look at it, and so we can look at data head. And basically what we have here is a data set of a bunch of different chemicals. We have molecular weights, we have critical temperatures, eccentric factors, and boiling points. And head just shows us the top, basically 5 entries in our table. If we want to extend it out, we could do data 10. And now we have kind of the first 10 in our data set. We can also look at the last ones, data tail. And this kind of gives us our last 5 compounds. Again, we could also do 10. And then we have kind of the last 10 in our data set. Again, name, molecular weight, critical temperature, eccentric factor, and boiling point. So that's kind of looking at our data sets. One other thing, so I'll just put this back to head so I can keep this here as a reference. You might also want to look at the statistics. So we could do data. Where did I do control? So data dot statistics, and let me do, I'm sorry, it's not data, it's data.describe. Let's see, describe. And what we have here is just kind of basically the statistics on our data set, and where we have kind of, molecular weight, we have, 6,031 entries for each of these 4 columns. Here's the mean value. We have the percentiles, the max value in all of our data. So that's kind of one way to just take a quick look at the statistics. Again, we have standard deviation means for all of our data sets, and this is useful for getting an idea of kind of what the range is for that. We can also grab things, so we could do like data dot 10 through 20, right? And basically this is going to give us rows 10 through 19, and so that's one way to kind of access different information. We can also do things like data dot, put in parentheses. This is why I kind of kept this here. So we could do like critical temperatures. And back is going to give us back kind of a data set that has our critical temperatures where we have kind of the row number and the values. But often what we're interested in is kind of like the values. And that's just going to give us back an array with all the different values for the critical temperature. We could also do this with the molecular weight by accessing this. So we could do molecular weight, and again, we're going to get back an array of values. Also, if we want to do multiple columns, so I could do molecular weight, comma, and let me put in here critical temperature. And let me close this off on another bracket right there. And now we're going to get back an array where the first thing we have our molecular weights, right? And in the second one, we have our temperatures. So we're getting back an array of values. And this is going to be useful for when we, if you want to do any kind of machine learning algorithms on it. The other thing you can do is access data. And I think I did this in one of the examples. We can grab, the first 10 through 20 rows, and we'll grab the 0th column. And back, we're going to get back, kind of the names. And I can do values here, kind of kick back the just the actual values, and I'm going to get an array. And since the first column is just going to be names, it's going to be an array of strings, right? So the string values are all the different names. If I did the first column, I'm going to get back an array of the values, and I can do slices, so I could do 1 through 3, and here I'm going to get back, it's going to grab the first and second row, so I have my first 2 rows of data, and if I want the next row, I could grab all that information in kind of my data.rows or my data.values. So again, it's going to be just a way to access the different values, and this is just in terms of index locations rather than using kind of names that we did up here. So that's kind of one way. And I forgot to mention that if I did like data, let me come back up here, and I did molecular weight, right? This is going to give me back all the molecular weights, but I could also grab, the 10th through 20th column. And now I have the 10th through 20th column for the data structure. And then I could also do values just to get this back as an array. So this is kind of the way you're going to access some of our information in it. One other cool thing is there's a lot of built-in kind of plotting functions with Pandas. So we could do like data. And which column do I want to grab? Let me come back up here. Let's grab the boiling point. Let me just copy and paste this so I get it exactly right. So I could do like data dot boiling point, and then what I could do is I could do something like plot dot hist, and then I'll do color is equal to red, and then I'm going to do bins is equal to 40, and then I could do plt show, right? And I'm going to get a histogram of kind of the value of my data.boiling point. The other way to do this is I could have also just done, if you don't want to do this accessing like this, I could do plt histogram. I could do data.boiling point. Let me just grab this up here, and I think I'm going to have an extra thing, and then I could do color is equal to red, and then bins equal to 40. So even though I'm doing it here, passing in the data structure, the histogram or plot will know what that's doing, but you can also do it like dot plot histogram. So that's another way to look at it. And if you go through some of the examples in kind of some tutorials, it'll also be fairly clear. I'll mention one other one we can do with built-in plotting. I could do data dot say plot, and then I could say x is, I'm going to come up here, and maybe we're going to grab our x is the molecular weight. So I'll just come up there, grab that, and I'm going to come back here. I have x is the molecular weight, and then I could do y is equal to, let's do the boiling point. And then, I could do color is equal to red. And then what I'm going to do is I'm going to do line style. So I'm going to get rid of the lines is equal to just NP quotes. And then what I'm going to do is marker is just equal to a 0. And so if I come over here, I do plt show. And again, so this is just slicing. Let me just zoom this out a little bit. So now you can see the full kind of command. Here I'm just putting different information in. I could do plt show. And it's going to have my plot with my boiling point, right? So that's going to be my y. And here I'm pointing my molecular weight. So that's one way to do it. The other way we could do a standard plot command where we plot data dot molecular weight versus data dot boiling point. And so that's just one way to kind of take in some built-in features in kind of our data set. So the last thing we might want to do is kind of do, say, a linear regression. So maybe we want to do how well does a molecular weight predict the boiling point. So what we could do is like model is equal to, linear model, and then we could do linear regression. We could use basically whatever tool you want to use here. And here we're going to set x. We're going to do data, and I'm going to do the double quotes, right? So here I'm going to do mole weight. And this is because this x is, of course, a two-dimensional array. And then y is just going to be data dot boiling point. And I want to make sure I get this exactly right. In the example I posted online where I kind of went through this, I'll show you how you can remap the names and things like that. And then I could do, model dot fit x comma y, and then I could do like model dot score x comma y. And you can see just basically a linear regression. You can get 58% accuracy. Um, but you can play around this a lot, using more factors. So maybe you could use the eccentric factor and the molecular weight. So maybe if we put in an extra variable like the eccentric factor, which, let me grab this because I will never spell this correctly. And I can have my second factor in here, and let me get rid of that. It was just a tab. And now I have two factors, and now I'm up to 71% when I count for these two factors in trying to predict the boiling point. And you could also put in the critical point. The critical point is definitely correlated with the boiling point. So with that, I think I'll stop. I put on Compass, I have a little bit more comprehensive example. But this is just kind of a quick overview of how you would use, Pandas to import a spreadsheet and then kind of do basically any kind of the normal analysis that we did. And I showed you a couple features within Pandas. Obviously, there's a lot more. I only know a small amount of it just basically to use it for machine learning applications, but I'm definitely not an expert. And if you really want to learn Pandas, I suggest going into one of the many tutorials online about it. So with that, I'll stop. And if you have questions, please post them in the discussion section or to, Piazza, or just send me an email. All right. Thank you.